This is chapter 11.6. We're talking about finding the volumes of pyramids. So obviously I have a cube here to begin with. Let's think about how we find the volume of a cube. We would just take side times side, and that would give us the area of the base. And then we would multiply that by the other side, and that would give us the volume of a cube. So the volume of a cube is the side cubed. I suppose we could say width times length times height, but since in a cube they're all the same thing, we're not going to worry about that too much. Now when we talk about a pyramid, and this is the first one I'm going to show you, would be the classic pyramid, where something like the pyramids of Egypt that have a square base, and then their vertex point here is right in the center like this, and so there's a back line here that we can't really see, and another one over here we can't really see, and then this one we would be able to see. The cube isn't in the way, and so you can kind of imagine this pyramid inside of our cube, I hope. That pyramid doesn't take up all the volume of the cube, does it? We have some space all around the upper part, especially that we have left over, and it turns out that the volume of the cube is exactly 1/3 the volume of the volume of the pyramid is 1/3 the volume of the cube. And so that formula, so for the volume of any pyramid, 1/3 the area of the base times the height will give us the volume of a pyramid. So in this case, if we just took 1/3 of the volume of the cube, we're going to have the volume of the pyramid. Okay, and it really doesn't matter the shape, particularly of the base. The base can be any sort of shape. I have a few different ones here. This one we just talked about, it has the square base, and this is kind of what we think of as a pyramid a lot of times. This one we would think of as a circular cone. We could still say it's a pyramid though, and its volume is still 1/3 the area of the base times the height. And if I kind of fill in the rest of this cylinder so you can see the circular cylinder, hopefully you can see that that circular cone is going to take in 1/3 of that. So if we knew, say the radius were 3, and we need to know the height of the cone, and that would mean from a right angle right there, and we'll just make it easy, we'll make it 10. So the area of our base would be 3 squared times pi, and then we multiply that by the height, which is 10. So we have 9 times 10, or 90 times pi. This is the volume of the circular cylinder, okay? The whole circular cylinder. The volume of the cone is just 1/3 of that. And of course we can do 1/3 of 90, 30 times pi, and that would be cubic units. And this is, again, that's the exact answer. You don't need to get out a calculator at that point. You can give me the answer like this, unless the instructions specifically say to give the answer to the nearest tenth or hundredth, or to the second decimal, or whatever it is. Okay. This is also going to work on this type of pyramid where the base is a triangle. Can you see the base down here? Okay. So if we have the height, which might come down like something like this, if we can figure out the area of the triangle, this is a right triangle, so if we knew, I don't know, this one's 6 and this one's 3, if we could find the area of that triangle on the base, half of 6 times 3. I can't stress the half enough. It seems like we forget the half a lot. Half of 6 is 3 times 3, that's 9, so that's the area of our base. If we have the height, we could find the volume of this pyramid. Or what if we knew the volume? What if we knew the volume was, I'm going to make this one really hard. I'm going to make it 90 cubic units. Could we figure out what the height is? So could we find the height if we knew what the volume is? Okay, so we know that the formula for the volume of this particular figure is 1/3 the area of the base, okay, area of the base, times the height. We don't know what the height is. We did figure out the area of the base, though, didn't we? It's 1/2 of 6 times 3. So we can figure this out again. It's 9, and we can say 1/3 of that is 3. If you prefer, you can say this is 1/6 times 6, which is 1 times 3, still 3. Okay, and so we know the volume is whatever 3 times the height is. And in this case, we're given the volume right off the bat is 90. And so you can see, if we just fill in all the parts of the formula that we know, we can figure out the part that we don't. So the whole thing turned out to be the volume is the area of the base, which is half the base times the height of the triangle times the height of the figure. I want to use capital H for the height of the figure. That's confusing. We have the height of the figure, okay, and then we have the height of the triangle, which is the base here. That does get a little confusing. So if we just fill in the parts we know, excuse me, I didn't put my 1/3 in there. 1/3 times 1/2 times the base of our triangle, which is 6, times the height of our triangle, which is 3, times the height of the figure, which we don't know. You just fill in all the parts of the formula that you have, and you have one variable left. You can figure out what the missing part is. Okay? Quickly now, YouTube doesn't like me uploading very long videos. Let's talk about scale factor here for a minute. We have 8 here, we have 4 here, so we can see our scale factor is either 1/2 or it's 2, depending on which direction we want to go. What do you think about the volumes of these two things? Do you think the volume here is going to be double the volume here? We saw that with areas, that the areas don't double when the lengths of the sides double. What do you think about volume? Okay, I'd like you just to add at the very bottom of your paper, the worksheet that I assigned today. I'd just like you to add your comment about what happens with the volumes. If the volume doubles, like in this case, excuse me, if the scale factor is 2, what's going to happen to the volume? Is it going to double? Is it going to quadruple? Is it going to go by 8? What's going to happen? Give that explanation for me on the bottom of your worksheet. Okay, good luck today. Thanks.